Dear students, welcome to my YouTube channel PCM Academy. From today, we will start the crash course for IIT JAM and CUET PG exam also, because you know the syllabus of CUET PG exam and the IIT JAM syllabus are very close to each other. If you go through the syllabus, then you can see one or two topics are different, and that topics I will discuss later on after finishing the common topics of IIT JAM and CUET. And this course, this is the revision course actually, this is the crash course. And this course will be very helpful for you if you are preparing yourself for any types of MSC entrance that is based on physics. So you will get any, you can appear any kinds of MSC entrance exams. Okay, other than IIT JAM and JEST. Okay, other than this kinds of exam, TIF, other than this kinds of standard exams, you also have some university exam, something like CUET. The very recent time, this is a trending exam, that is CUET. PG exam and UG exam. So you need to follow the CUET PG obviously. And another thing is that various states universities also conducted their entrance exams, and the syllabus is more or less the BSc syllabus actually. So the syllabus will be more or less same. After finishing the common topics of all the exams, I will discuss other topics which are very special for a particular exam, that I will tell you later on. Okay, so we will start from the very basic points of classical mechanics. And the first topics that is going to discuss I am here is the coordinate system, that is the velocity and acceleration in various coordinate system. You know there are various kinds of coordinate systems, something like polar coordinate systems and Cartesian coordinate system, but here Cartesian coordinate, the velocity and acceleration in Cartesian coordinate system, Cartesian coordinate systems are basically for 10 plus 12 level, 10 plus 2 level questions are asked in that. So that you have already covered in your 10 plus 2 level. But here what we will going to discuss about the basically for polar coordinates. Okay, something like plane polar coordinate, and then we will discuss about the cylindrical polar and spherical polar also. So first let me tell you what are the expressions of velocity and acceleration in plane polar coordinate systems. As you all know, the plane polar coordinate system, there is an initial line and the position vector of any point is r, which is making an angle theta with the initial line. So this line you can take as initial line with respect to which we will measure the position. So this point is actually, the coordinate of this point is r comma theta, and this r cap is the unit vector in the direction of increasing r, and theta cap is the unit vector in the direction of increasing theta. Okay. Now what are the velocity? So the velocity of this particle, if the particle is moving along this curve, the velocity of this particle will have two components. One is along r cap and another is along theta cap. Okay. So that will be Vr r cap and V theta theta cap, and this Vr will be r dot. Here r dot means simply dr by dt. And V theta is theta, r theta dot, that means r into d theta by dt. Okay, so this is your velocity expression, and this has two components. You need to remember these results also, that is r dot r cap and r theta dot theta cap. And then the acceleration will also have two components. One is along radial component, that is ar r cap, and another is along transverse component, that is a theta theta cap. And the magnitude of ar is r double dot, that means d2r dt2 minus r theta dot square r cap plus r theta double dot plus 2r dot theta dot. Here dot means actually the one dot means the first derivative with respect to time, and double dot means the second derivative with respect to time. So if you talk about r dot, then obviously it is dr by dt, and if you talk about r double dot, then it will be d2r dt2. Similarly, if you talk about theta dot, then this is d theta by dt, and if you talk about theta double dot, then it will be obviously d2 theta dt2. So these notations, with this notation r dot and theta dot and r double dot theta dot, you have to remember this result, and we will use later on these results in problems. So basically at the end of the day, what you have to do, you have to solve problems by using this formula. So in this crash course, I have arranged the course in this way that only I can discuss the concepts and I can discuss the problem based on that concepts and formula. Okay, so now we will discuss about the cylindrical polar coordinate system, velocity and acceleration in cylindrical polar coordinate system, and in spherical polar coordinate system also. Okay. Now in cylindrical coordinate system, there is an extra term, that is Vz, because here in the coordinate system, the coordinate of any point is r comma theta comma z. So in the plane polar coordinate, what we have only r comma theta, but here r theta and z. Okay, so here three directions are possible. One is along r cap, another is along theta cap, and another is along z cap. So three terms are there, but the simplified thing is that here the first two terms are same as we have discussed in the plane polar coordinate system, but only in the third term, that is Vz. So instead of Vz we have z dot, and instead of az we have z double dot. Otherwise all the terms are same, you can see as we have seen in the plane polar coordinate system. So here what will be your v will be r dot r cap, r theta dot theta cap, and z dot z cap, and in a that will be r double dot minus r theta dot square r cap plus r theta double dot plus 2 r dot theta dot theta cap plus z double dot z cap. Okay, so only one extra term is there in velocity expression and is in acceleration expression. But in spherical polar coordinate system, next let us see about the spherical polar coordinate system, and in that case you can see the major change. Okay, so let us see now the velocity and acceleration in spherical coordinate system also. Now in spherical polar coordinate system, you can see the velocity expression and the acceleration expression also, but the velocity expression is more simple, but here the acceleration expression is very difficult to understand, to memorize or to remember. So don't worry, you don't have to remember this expression because generally questions are not asked directly from this expression, but you need to only memorize about this expression, that is v is equal to r dot r cap plus r theta dot theta cap, and these two terms are same as before, and here is r sin theta phi dot phi cap is extra, but here the expression is too difficult to remember. So you can see the first terms are same, that is r double dot minus r theta dot square, that was also previously, but here this terms is again a new term, that is minus r phi dot square sin square theta. So this is the r component of radial component, and the theta cap, the component along transverse is this. Here also first two terms are same, 2 r dot theta dot plus r theta double dot minus r sin theta cos phi phi dot square is a new term. Similarly, this term is completely a new term, that is 2 r dot phi dot sin theta plus 2 r cos theta theta dot phi dot plus r sin theta phi double dot phi cap. So this is the total acceleration component, acceleration expression, and these are the each and every component of this acceleration, total acceleration. But you don't need to memorize this thing, you don't need to remember this thing, because generally questions are not asked from this expression directly, but at least you need to remember this expression, that is the velocity expression. Okay, so these are the expression of velocity and expression of accelerations also in three different coordinate system, that is in plane polar coordinate system, in cylindrical coordinate system, and in spherical polar coordinate system. Okay, so now let us solve some questions based on these expressions asked in previous year JAM questions, and also some extra questions we will practice now. Okay, question is asked in JAM 2007. Here what we have to find out? We have to find out the radial and this r component and the phi component, that is the phi cap, along phi cap, the acceleration of this particle at highest point p. So you can see this is the projectile motion, and the projectile is projected at an angle 45 degree. So let me suppose that the velocity of projection or the speed of projection is, you can say this is u, suppose. So this is the angle of projection 45 degree, and what we have to find out? We have to find out the radial and transverse component of acceleration at highest point. This is the highest point. So we have to find out this r cap and phi cap. So what we have to take? We have to take this line from this point of projection, actually this is O, from this point, and this is actually the highest point P. So we just connect this OP, and let me suppose that this angle is phi and this angle is given as 45 degree. So if this angle is phi, this angle will also be phi, very simple geometry. And now the radial component is along this and the phi cap is along this, because this is increasing direction of phi cap and this is the increasing direction of r cap. So what will be the component of acceleration? You can see from here that the acceleration AR will be along this direction, but if you take the component of G, so here acceleration means G, gravitational acceleration, and the component of gravitational acceleration along r cap and along phi cap we have to find out. So what will be the component of G along this direction? You can see this is G cos phi, and along this direction this is G sin phi. So opposite to G sin phi there is r cap. So AR will be nothing but minus G sin phi, because this is in opposite direction, r cap is in opposite direction of G sin phi, and the component of G along this is G cos phi, and this is also opposite to phi cap. So what will be A phi will be also minus G cos phi. Now if you once find out sin phi and cos phi, then you can easily find out AR and A phi. So how you can find out sin phi and cos phi? So let me consider this triangle. You can see this is a right angle triangle and this angle is phi. So we can easily find out tan phi. So this is the range of this projectile. So this is the range, half range r by 2, and this is the maximum height of this projectile h. So you can easily find out that what will be tan phi. So tan phi will be nothing but h divided by r by 2, that means 2h by r. Now what is the expression of h and what is the expression of r? You know from your basic concept of projectile motion, because you know that h is nothing but u square. If velocity of projection is u, then u square sine square, here 45 degree is the angle of projection, divided by 2g. Okay, this is your maximum height h, and you know sine square 45 is 1 by 2, so it will be just u square by 4g. And now what will be your r? So r is nothing but you know that is u square sine 2 alpha, here sine 2 into 45 degree, so sine 2 alpha divided by g, Okay, so u square sine 2 alpha by g. So what is u square sine 2 alpha? You can see 2 into 45 degree means sine 90. So this sine 90 is 1, so it will be just u square by g. Now you can easily find out from here that what is 2h by r. So what is tan phi? You can see what is tan phi from here, you can see. So 2h by r, so 2h means this. So if this is 2h, then it will be 2u square by 4g, that means u square by 2g. So here is u square by 2g and here is u square by g. So u square by g and u square by g will be cancelled out, and that will only be half. So our tan phi will be half. If you divide this, you can easily understand 2h by r. So it will be tan phi is equal to half. Now from here we can find out cos phi and sin phi. So if your tan phi is half, then obviously your cos phi will be what? So you know, if you draw a triangle over here, for this angle is phi. So this tan phi is 1 by 2, that means your perpendicular is 1 and base is 2. So your hypotenuse will be root 5. So what will be your cos phi? So your cos phi will be base divided by hypotenuse. So it will be 2 by root 5, and your sin phi will be 1 by root 5. So sin phi will be 1 by root 5. Now if you substitute this value here, what you will get? You will get AR will be minus g by root 5, and your A phi will be minus 2g by root 5. Okay, so this will be your answer to this problem, and there are option obviously, so you can match this option, the option from this calculation. So this question is asked in JAM 2007, and you can see from this problem that the question is not from the direct formula, but the concept is same about the radial and transverse, along the direction of transverse and the radial direction. Okay, so sometimes you have to solve the questions conceptually only by following the directions and component of g, something like this. Okay, so this question is very important, asked in JAM 2007. But in JAM 2009, there is a question that is directly the formula based questions. I am not going to write these questions because I have already told you about the cylindrical coordinate system, plane polar coordinate system, and the spherical coordinate system. So the question is directly asked which is the expression for velocity and acceleration of cylindrical coordinate system, and there are 4 options, and I have already written the expression, so you can easily match. So that question was also asked in JAM 2009. So now let me tell you one more questions that is also very important, was asked on in IIC 2008. Okay, so let me solve these questions also. So this question is asked in IIC 2008. So what is the questions? The trajectory of the particle is given as r of t is equal to r0 sin hyperbolic omega t, and this is given in cylindrical coordinate system. Also provide that z dot is equal to 0 and phi dot is equal to omega. So our z dot is equal to 0, and r0 and omega are also constant. So the radial force is, so what will be your radial force? So first what you have to do, you have to find out the radial acceleration, and now if you multiply this with the mass m, then you will get the radial force. Now you know the expression of radial component of acceleration in cylindrical coordinate system. So you know in cylindrical coordinate system the radial acceleration AR is nothing but r double dot minus r phi dot square into r cap. So this is the magnitude of radial component of acceleration in cylindrical coordinate system. This is same as in polar coordinate system also, but here in terms of in place of theta we have defined it as phi. Okay, so your radial component is r double dot minus r phi dot square. And phi dot is nothing but omega, and omega is constant. So you don't have to do anything about this expression. So what you need to find out this r double dot from this expression, simple. So here what is r? Here you can say r is r naught sine hyperbolic omega t. Now if you differentiate with respect to t, so what we will have? You have r dot, and the differentiation of sine hyperbolic is cos hyperbolic, so it will be just cos hyperbolic omega t, and one omega will be outside, so it will be nothing but r0 omega cos hyperbolic omega t. Now if you again differentiate this expression, then what you will get? So if you again differentiation, then you will get r double dot, and that will be again this cos hyperbolic will again converted into sine hyperbolic, but there is no negative sign. Please remember, for hyperbolic function there is no negative sign. So because in general you know the derivative of cos is minus sign, but for hyperbolic sign it is not minus, it is just plus. So cos hyperbolic, the differentiation of cos hyperbolic is again sine hyperbolic, is again sine hyperbolic omega t. Okay, and again one omega will be come out, so it will be r0 omega square. So it will be just r0 omega square sine hyperbolic t. And if you see this r0 sine hyperbolic t omega t, this is nothing but r. So this r0 into sine hyperbolic omega t is r, so it will be just r omega square, r omega square. So now if you put here, you can see what will be your ar. Ar is just r double dot is nothing but r omega square, and this phi dot is also omega is given here, so this is also omega square. So this will be r omega square minus r omega square, so this will be 0. So once your acceleration is 0, so obviously the radial force will also be 0. So option D is correct. So this is also a very good question that was asked in IIT 2008. Though this exam is not exist now, this IIT is merged with IIT JAM. So IIT is taken admission from IIT JAM and JEST also. Some seats are for JAM and some seats are for JEST also. So this is also a very good question, and please remember, most of the questions in CUET and various state exam is repeated from this kinds of exam from IIT, IIT JAM, JEST. So you have to see the questions, previous year questions of this kinds of standard competitive exam or MSc entrance. Then you can easily solve the questions that will be asked in your various state MSc entrance exam and the central university entrance test also. That will also be helpful, these kinds of exams, these kinds of questions that are asked in previous year questions. So that after discussing the theory, I am going through the previous year questions from the topics. Okay. Now let us solve this question. If the radial and transverse velocities of a particle are always proportional to each other, show that the path is equiangular spiral. So what is given here? Radial and transverse velocities are proportional to each other. So what is radial velocity? That is r dot, that means dr by dt. This is r dot. And what is our transverse velocity? That is r theta dot, that means r into d theta by dt. Because you know from the velocity expression in plane polar coordinate system, that is r dot r cap plus r theta dot theta cap. So r theta dot means r into d theta by dt, and r dot means simple dr by dt. So what is given here? These two are proportional to each other. So this will be equal with a constant k. So k is a proportional constant. So this is our expression, that is dr by dt is equal to kr into d theta by dt. Now if you rearrange this equation, so what we have to find out? We have to find out the trajectory. That means the expression of r. Okay, so what will be r? That will be trajectory. So it will be dr by r. So dt will be cancelled out. So it will be k into d theta. Now if you integrate, then what you will get? This dr by r will be ln r, and that will be k theta plus some constant ln c. This is the integrating constant. So it will be ln r by c is equal to k theta. So your r is equal to c e to the power k theta. C e to the power k theta. So this is your trajectory, and this is nothing but the equiangular spiral. So this is the equation of equiangular spiral. Okay, so these kinds of questions